This video will be about finding the greatest common factor. So when you're looking for the greatest common factor, it helps to break down each term. Let's say we have 18y cubed and 12y. If we're going to find the greatest common factor between each of those two things, we're going to break them down to their most basic parts. So we're going to do what's called a factor tree. So I want to think of two numbers that multiply to be 18. It can be any two numbers, it doesn't matter which. You'll get to the same place. So I'm going to use 2 times 9, but you could have used 3 times 6. So we're going to keep breaking each of these following numbers down until we get a prime number. A prime number is a number that you can only find numbers that multiply to it that are 1 and the number itself. So like 2, the only numbers that multiply to be 2 are 2 times 1. That means I don't actually want to use that because it involved a 1. We don't like that. That's what makes that a prime number. But 9, you could do 9 times 1, but you could also do 3 times 3. 3 and 3 are both prime because the only numbers you could use are 3 times 1. 3 times 1. So we don't actually want to use those because they're prime. Now when you're breaking it down, 9 is not going to be part of this anymore because it was broken down to be 3 times 3. We can also break down the letters. Y cubed is the same thing as y times y times y. So now we have 2 times 3 times 3 times y times y times y. We brought everything down that it was broken into, down into. So now we do the same thing with 12y. Things that multiply to be 12 are 4 times 3. You could have used 2 times 6. 4 times, things that multiply to be 4 are 2 times 2. So now we have prime numbers again, 2 times 2 times 3. Y can't break down any further, so we just bring it down, so times y. So now, with these two terms completely broken down, I'm going to put a kind of squiggle in the middle to show they're two separate things. Well, now we want to find things they have in common. The first one has a 2, the second one has a 2. It has a 3, the second one has a 3. But the first one has a second 3, and the second one doesn't, so we actually don't use it. And they both have a y in common. So what they share in common are a 2 times a 3 times a y. If we simplify that down, we get 6y. So that means 6y is the greatest common factor. What else you can do with this is it may ask you to actually factor something. If we're going to actually factor something, first we have to find the greatest common factor, and then we have to do some dividing. So let's say we want to factor 3b to the 5th plus 14b squared. Again, we're going to break these down as much as possible. 3 is already prime. B to the 5th can be written as b times b times b times b times b. 14, b squared. 14 can be written as 2 times 7. Those are both prime, so we have 2 times 7. B squared is b times b. Again, we look for what they have in common. They don't have any numbers in common, but they do have 2 letters in common. So the greatest common factor would be b squared. So what they have in common would go outside, and you're technically dividing each of these by b squared, so each of these by b times b. So to figure out what's left over, we would have everything else left after you've divided. Well, b divided by b cancels, b divided by b cancels, so we have 3 times b times b times b. All that's left over here is 2 times 7. And then we just simplify b squared. So There are 3 b's together, which is b to the third. 2 times 7 is 14. So you break it down as much as you can. You find what they have in common. That common piece goes outside, and then the leftovers go inside the parentheses. So one last example just for some more practice. 24z to the 7th plus 12z to the 5th minus 30z squared. Again, we start by breaking down the number. Things that multiply to be 24 are 6 and 4. 6 is 2 times 3. 4 is 2 times 2. Again, we don't use the 4 and the 6 because they got broken down. Usually when we write it out, we go in order though, so 2 times 2 times 2 times 3, since all the 2's are smaller than the 3. And then z to the 7th, we're going to have to write z out 7 times. 5, 6, 7. Plus whatever we get when we simplify the next term. 12 is 4 times 3, and 4 is 2 times 2. So we'd have 2 times 2 times 3 times z to the 5th, so z 5 times 5, minus 30 broken down as 6 times 5. 6 is 2 times 3, 5 is already prime, so 2 times 3 times 5. Z squared would be z times z. So now we look for what they have in common again. All of them have 1, 2. But if we go to the second 2, the third one doesn't have another 2. So we only use 1, 2. Looks like they all have 1, 3 in common. And then it looks like they have 2 z's in common. So what they have in common would go in front of the parentheses. And then you leave the stuff inside the parentheses that is left over. So we're getting rid of all the things we've circled and just using everything that's left. 2 times 2 times z times z times z times z times z plus 2 times z times z times z times z minus 5. And then we reduce everything. 2 times 3 is 6. Z times z is z squared. 2 times 2 is 4. Z times z times z times z times z is z to the 5th. There are 5 of them. And then z times z times z times z times z again is z to the 4th this time. Oh, except I just noticed I made a mistake. I didn't circle the second z in that middle section. So one of those should actually be gone, and this should actually just be z to the 3rd. Sorry about that. Minus, and then the last one doesn't have anything to simplify with, so just minus 5. So that is how you find the greatest common factor and how you factor a polynomial using greatest common factor.